Hello everyone, you're welcome to yet another lecture in the series of videos where we focus on how to handle numbers. In this particular recording, we will be focusing on a little bit of trigonometry. That sounds a little bit scary, but it is not. And I'm not trying to, give you any extra boost. Just open your mind and let's see what this means. Now, in secondary school trig, we were told a lot of things about angles, about what we knew as SOHCAHTOA, which was sine means opposite over this, uh, you know, cosine means this and that, tangent means this and that. Even when you write the name there, you just see that so is opposite over hypotenuse, chi is adjacent over hypotenuse, toa is opposite over adjacent. This is the way you deal with it when you are thinking about, right angle triangle. But when you take your geometry knowledge to the next level, you will recall that we weren't being given angles in degrees all of the time. There were instances when angles were given to us in pi radians. And a lot of people will be like, oh my God, what is he talking about again? Yeah, it's true. So what exactly is the concept of radian about? It's a way of saying when you look at your circle and you check, I had to pull this up from somewhere on the web. Credit to whoever posted that. I think I'll get the source and post it as a description comment. Now, when you look at a circle, this is the center of the circle. This is the radius. Any line drawn from the center touching any part of the circumference without going outside of it is the radius. So any line that you draw, all these ones, imaginary lines, will be radii. Now, if you move from, let's say you started from here and you go to the edge here and you have your radius and you move along the circumference over a distance that is exactly equal to the radius, then we'll say the angle that you have covered is 1 radian. 1 radian. And if you continue to move that way, you realize that the second radian will be somewhere here. The third one will be somewhere here, even though you've not closed the horizontal line, which is the diameter of the circle yet. So technically, you will be having something like 3 point something as the number of radians you will find on a semicircle. And if you close up the loop, it will be like 6.2, 6.3 radians in a circle. So how does this affect you? You do not need to even memorize this because Python now allows you to do conversion from degree to radians and then radians back to degree. So how do we go about doing that? So let's say we go into radians first, and then someone has given you 180 degrees and they want you to convert it to radian. What you simply do here is to say math dot radians of what? The x degree that you have been given. This time around, we have our x degree as 180, but that is equivalent to how many pi radians? If we run this, I think your answer should be pretty much what I said. Pi, 3.142. That's horizontal stuff. If you change this degrees to 360, which is the full circle, you will get the result as 6.283. That's when you are converting from degree to pi radian. And you can see the way I have formatted my results. I said degree, 360 degree is whatever the result is in radian. Okay. In fact, you can come in here and say in radian, and then the result will still be the same. It's cool. But how about when we want to do radians to degree? We can go back here and say, this time around, we want to move from radian to degree, not degree to radian. So let's say 1 radian is equivalent to what in degrees? I have no idea. So I'll come in and say There is math.degrees, which is expecting something in radian. So say pass this variable x radian to it and then give me the results. It should be like 57.29. Awesome. So I've learned something. So 1 radian is 57.296 degrees. That's the way you do the conversion. But one thing you should have seen here is 180 degrees is equal to pi, technically, because we saw that in this example. When I came in here and I put 180, it gave us an output of 3.142, which is the same as pi. So we can play around with that subsequently when you get to sine, cosine, and what have you. So if we go into sine and someone is telling you, give me an angle, say what is 30 degrees, for instance. 30 degree to me will be math.pi divided by 6, because I know this is 180 degrees, and then if I'm dividing it by 6, that will give 30, and that is what will be stored in angle. So the sign of that will be math.sine. So what is the sign? I'll put angle here, and it will do the mathematics of sine this, and I guess this should be 0 0.5, 0.4999. It's roughly 0.5. You can copy the same idea. This is my angle 30 degrees. If you don't want up to that, you can say what is angle 60 degrees. This is 180 divided by 3 will be 60, 120, 180. Yeah, so this is angle 60, and it's going to give 0.866. So you can play around with these numbers and then you see what the result is going to be. So I'll go out of here and go to my cosine and say, hey, cos, we're not giving the angle as 0. Rather, we want to give you 30 degrees like this. What is the cosine of it? I'll do math.cos, and then I'll pass the angle. So you don't need to go and check any log or four-figure table, as we used to call that book back then. Python is going to solve this for you right away once you pass in the parameters correctly. So this is the cosine of 30 degrees. And if I go into my tangent, which is here, I'll pass my correct angle to it. This is 30 degrees. And I'll say math.tangent of that angle, which is our input, and the result is going to be 0.5774. I don't need to verify this because I know Python is going to give me something correct. Now, if you wanted to do the reverse of all of this, how would you go about doing it? Remember, we talked about sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, tangent meaning opposite over adjacent, opposite over adjacent in your right angle triangle. If you want to flip all of this, it will be 1 over all of those figures. But you don't have to start doing the reciprocal of those numbers. Python can do that for you easily, because if you come into cos here, which is the reverse of the normal sine, you will come in and say, that's your angle. I need you to do the reversal for me. And then I need the angle there, ANGLE. And then I typed O here, or 0 there in error. So this is going to give me the reversal. I typically want to clear my screen in the terminal before I run. And then I get the result. This is the reverse of your cosine operation. You can do the same thing for your sine, passing the angle that you need. I keep using 30 degrees because I don't have the luxury of time. You can pass whichever angle works for you into that slot. The main idea is that you should know how to do math.arcsine. Yeah. And then passing the angle, and the result is going to be printed for you. Say arc sine of this angle is this result. We clean our screen again, we run this code, we get our result in here. And then the last one here is the arctan. Can you guess what the result is going to look like, or the code? I'll come in here and say that's my angle that I am passing, 30 degrees, because math.pi represents 180 degrees, and I'm dividing that by 6 to give me 30. And here I'll say math.atan, which is your arctan in trig, and I pass my angle to this. I'll clean my terminal, I'll run this code, and then I have my result. This is the way people who do maths at supposedly advanced level can go about empowering themselves using Python to automate most of their mathematical calculations. So in this short video, we've been able to cover some fundamental elements of trigonometry. We've seen how to convert from radian to degree and from degree to radian. We've seen how to calculate the sine of any angle, the cosine of any angle, and the tangent of any angle. And we've also seen how you can do the reversal of sine, cosine, and tangents. I hope this is going to be useful to you, regardless of whether you still remember your maths or not. You may need to teach your kids how to do some of this as their homework from school. If daddy, mommy can still do this, then you're inspiring your kids to take their math seriously. Click on like, share this video with people, subscribe to the channel if you find the content useful. Let me have your comment. Thanks a lot for joining me. I see you in the next recording. Bye for now.